right, so here are the formula that we need to, you can use these to find the derivative of any exponential function as long as u is a differential function of x. And the second one we can use to find the derivative of any logarithmic function as long as u is a differential function of x. Which of course they will be given that way.
I would just change the log into an exponent. Can you go over that real quick?
All right, so we'll do a review on that. That's good. So we have, let's say, the log of, let's say, base a of x to the d. That's the same statement as saying, actually, let's do it as an equation. Yeah, let's do that. I say this equals, let's say y. So we have, this is the same statement as a to the power of y is equal to x to the power of b. So whatever the base is, you raise it to, if it's an equation, you raise it to the right-hand side of the equation, and that equals whatever you're taking the, it's called the argument. Whatever you're taking the log of, that's what it equals. So it allows you to undo exponents. Like when you solve problems algebraically in the past, if you had, let's say, e to the x is equal to 42, and you wanted to solve for x. Okay, you could take the ln of both sides. So you'd say, okay, the natural log, which is log base e, ln of e to the x is equal to the ln of 42. And doing this because knowing the rules of logarithms, if you have the log of any base of something that has an exponent, that exponent can come out to the front. So you'd have x ln of e is equal to ln of 42. And if we continue this problem up here, then x would be equal to ln of 42 over the ln of e. And then ln of e, okay, what is that? That's like saying, okay, that's the value that if I took the base, which isn't written, it's understood to be e, so it's ln, natural log. E raised to what power gives me e? 1. So this is just 1. So x would be equal to just ln of 42 over 1, which is just ln of 42. And that's the only way you could really write. You would not write this in decimal form because it would be irrational. So that's the most perfect way to write that. But here's log. So logarithms, it's like they allow you to undo exponents. Because like when you first learn arithmetic as a kid, it's like, okay, you learn addition. Well, how do you undo addition? Subtraction. You learn about multiplication. How do you undo that? Division. Then you learn about exponents, and then to undo exponents, logarithms. Okay? This is something you should definitely know, but it's not really the primary focus of what we're doing right now, but you should definitely know this basic facts about logs. It's a good question.
Number 7.
All right, so number 7 on the homework. So number 7 on the homework on page 178, it says that y is equal to x times e squared minus e to the x. Okay. Now e is a constant, so when I see e squared, that's just a constant raised to a constant, which is another constant. So in my mind, e squared, in terms of dealing with differentials, is just as easy as dealing with something like a number like 3 or 2 or 1/2. It's just a constant. So if I want to, this is what define dy dx. Yeah, so define dy dx. Okay, so the first part, you can look at each one individual. In fact, just to be safe, I will make this plus negative, just to make it crystal clear. Know that each term is separated by addition. So if I look at the first guy, what I see here is the way I look at it in my mind is I see this. I see e squared times x. Just like I would see the value 3x, for example. So the derivative of this is really easy. In fact, I shouldn't have written like that because I'm talking about dy dx. The derivative of this is just e squared. Just like I said, if it said x3, which is a weird way of writing 3x, well, the derivative of 3x is just 3, just the coefficient when it's, just x.
Okay, well that makes a whole lot.
So that's just, derivative of this is just e squared.
Because that's like the number in front of the x.
Exactly. This is like the number in front of the x, just written in weird, it's written in the back.
Any x is a coefficient.
Exactly. So, yeah, this is just like, you can think of this as like this. If I had y equals x times 3 plus a negative 3 to the power of x. When you see e, it's like, just like pi is a constant, e is a constant, just like 1/2 is a constant. It's just a constant, just a regular number. All right, so what do you mean about this x? Well, what would be the derivative of, if I rewrote this as y equals...
it's just 1. The derivative of x.
Yeah, I mean, if you did it like product rule, if that's what you're thinking.
How would you do it?
Well, this is just a simple power rule. This is just simple like x to the first.
Yeah.
If I took the derivative of this, 1 to the front, 1 times 3 is 3, drop this down to x to the 0, and x to the 0 is 1, 3 times 1 is 3. Technically, but when it's just something x, it's just a coefficient of the derivative, yes.
I thought the first step was just to write a to the u. So why don't yeah,
Oh, I'm not done yet with this.
Yeah, but the
We're
first
not
step
done
is
yet.
to write a to the u, right?
The first step. Are you talking about these guys, these formulas?
Yeah.
These are useful if I have to use them. If I have to say, okay, if I want to find the derivative of...
Isn't that what we're doing? I thought that's what we were doing.
If I want to find the derivative of some constant raised to some differentiable function of x, absolutely I would use this.
So you
Absolutely.
Why don't you use it?
I haven't used it yet because I really haven't had to, because it's something as simple as this. The derivative of 3x is just...
exponent, because the exponent isn't an x, right?
Yeah. Again, e squared is just a constant.
Okay, because the
It's just a
exponent
constant.
isn't x. You have a
Yeah,
number
this-
for the exponent.
This is just a constant. So this whole
Like
thing,
any other derivative.
this e squared is a constant. So this is just like finding if I had y equals 3x. The derivative of 3x is just 3. So the derivative of x e squared is just e squared. It's a good problem that it makes you look at what actually is being said and not overthink it, I guess you could argue. Now this guy here, I'm definitely going to need to apply the formula we're talking about because I have some constant raised to a differentiable function, and yeah, it includes a variable. Yeah, exactly. Okay. So plus negative this. Now technically you could think of it as -1 times that if you think about product rule, right? Because be careful. This is just e to the x. It's not negative e to the power of x. Okay, so that negative is going to hold. Okay? So if we continue with this problem, if I view this as like product rules, derivative of the first is 0, so that goes 0, plus leave the first one alone, which is -1, times the derivative of e to the x, which is just e to the x. When it's the derivative of e to the x from last lesson was just e to the x. It just keeps repeating. I could technically apply this formula for it, but okay, so it would be e to the x times the ln of e, which is 1, times dx dx, which is 1. So you have e to the x times 1 times 1, which is just e to the x. So that's why the derivative of e to the x is e to the x. So this would be the answer for 7. Yep, same thing. When I say plus negative, it's the same thing as saying minus, yep.
Basically, which function you use depends depends on where the x is. That's kind of how you tell everything.
Yeah, you could say that.
Exponent, it's
gonna be a different
the
beast.
exponential function.
Yeah, different beast
If
than.
x is like, like it normally is,
Part of
then
it,
you
yeah.
just do like product rule or power rule or whatever.
Yeah, exactly. And if x is the argument of, say, sine function, then you have to know the derivative of sine is cosine and all that.
Yeah.
Yeah.
Because this is like a, and in the book, they move this forward. Yeah, the derivative of cosecant x is negative.
Anyone comparison? All right, so for number 9, we have y is equal to e to the power of the square root of x. And we want to find dy dx. Okay? I can definitely tell you that when you deal with radicals, convert them to exponent form. It's just so much easier to see, I think. So I'm going to rewrite this guy as y equals e to the power of x to the 1/2, right? Because the square root is the same thing as the 1/2 power. Okay? So now let me take the derivative. Okay? So the derivative, according to that one rule, says it's going to be whatever the constant is to wherever it's raised to, leave that alone, times ln of whatever this guy was, times the derivative of this with respect to x. So actually, I'll write the whole thing. So it says that dy dx should be equal to whatever this guy is, leave it alone, times the ln of whatever the base was, which is e, times the derivative of this with respect to x. So the derivative of x to the 1/2. And that would be all the parts. Yep. So then edits like all. I should just do what? I end up writing big, I shrink it, and then I write small. So you're right. I don't know why I don't start off writing small. I don't know.
Because when you have so much space, it's just naturally.
Yeah, it's probably that, yeah. All right, so this equals, this is 1. So I have e. So I have e to the power of x to the 1/2, which I'm just going to rewrite as the way they started. And I emphasize this because you have to recognize these. I mean, of course, turning the papers to me, I'm not going to care whether you did like this or this. But as you're teaching, you're going for the AP Calc exam, you need to recognize when they give you responses that are in the original radical form that they gave the y in. So anyway, so that times 1 times the derivative of this is 1/2 to the front. X, drop this down, so it's just simple power rule, to the negative 1/2. And then remember that this is going to be, of course, this is just times 1. I'm going to leave that guy out. But here, think about what this is. When it's to the negative exponent, you can drop it underneath, do its reciprocal and make it to positive. So it's the same thing as 1 over 2x to the positive 1/2, which, in case you need to know, which you should definitely recognize back in radical form, that this is equal to dy dx is equal to, now this here is, you can write square root of x, e to the square root of x times 1 over 2 times the square root of x, which they might leave it like this, but also recognize in case it's a multiple choice question on the exam, that of course I could put this on top, right? Right? I could also rationalize the denominator, but I don't think I've seen problems where they care too much about rationalizing the denominator. But you guys should know that back from the day where, okay, I have to rationalize this because I have an irrational right now. I multiply the top and the bottom by the square root of x. So you get square root of x e to the power of the square root of x all over 2x. This would be the most perfect way to write dy dx. But again, for your exam, they may stop here. For a multiple choice, they may stop here at any point. But this is something you should be able to go all the way.
But you don't care what form for your.
Yeah, for me, when you turn in like a quiz or a test, I don't care, but I'm just saying for your sake, definitely know exponent versus radical form and all that.
Right.
Hope. You beat you to it. I'll get you next. Number 13.
Yeah, go 18, please.
Alright, so 13 first.
And then can we just do like 13, 15, 17?
Yeah, I'll
18?
just do them all if we have time, that's no problem. Yeah, and then if you guys need to focus on implicit, if we have time, we can, but I think that you guys seem to get it. And when I was looking around from what I observed yesterday, you guys seem to get implicit pretty well. Yes, you may. Thank you for asking. So we have this. So here we go. You guys are going to find out real quick that I do not memorize some of these because I've already taken this a long time ago. So I don't know the derivative of cosecant off the top of my head. I don't need to know. I don't need to know it, but you guys need to know it. What is it? Beautiful. Now there are tricks. Like when it's starts with a C, it's negative when you get derivative. Yeah. So here, so the rule is because this is an exponential. This is an exponential function. Leave it as it is. Times the ln of 3 times the derivative of this.
And that's it, right?
Well, whatever then, yeah, just go ahead and write that out.
Yeah, and the derivative you can leave it like that. That one wasn't that big for me. I just had to remember. And then it was 2 I got it. It is?
And what was it, Jessica?
Negative cosecant x times cosecant.
Thank you. And then however you want to arrange it, usually they'll take the negative. They'll take the negative and stick it in front of the ln. So this could also look like this. Negative ln of 3.
And it'll work all the way up.
So that, and however they might arrange that, you know, they might stick the trig functions in front of everything. Just whatever. Well, what is that one? The derivative of data is what?
Keeps the mathematicians away.
Memorizing a derivative of thing.
Oh. Yeah, there's quite a few you have to.
And then we should memorize.
We'll get there though, piece by piece.
These equations. We'll get there.
We'll
We're
get
starting
there.
with the
We'll do
derivatives.
it. I don't want to do that one. We'll memorize everything eventually.
All right.
All of the different.
Okay.
Anyone need more time on this?
Oh, no, I just searched differently.
Oh, because x can't be 0. All right, it's going to be -2.
15?
Yeah. I think I got it. Yeah.
So 15 says
It's over.
y is equal to the natural log of x squared. Okay, so for this one, I could use the long formula, but I know when it's ln, it's just 1 over whatever this is times the derivative of whatever this is. And the reason that is,
Oh my god.
the reason that is because of this situation here. ln of e again is 1.
Wait.
Wait.
I'm confused.
Yeah, it's 1 over. Wait, I thought if you just write the whole thing out. Like,
I thought-
makes sense, but like, wait. I thought the derivative of ln of x is 1 over x.
What's that?
Ln of x.
Yes, the derivative of ln of x is 1 over x. That's true.
So the derivative of ln of x squared is 1 over x. Right?
Times 2x.
Yes.
Yeah, exactly. So,
No, crazy.
yeah, so y prime.
And then the other one is.
And you know what? I'll go ahead for now because your quiz tomorrow is going to have different things besides just ln. ln is one of the most common ones for natural reasons. Yeah, you got it. Good. Okay, so it would be 1 over u ln of a times du dx. So 1 over x squared, the ln, the base of this log was of course e, times the derivative with respect to x of x squared, which is equal to 1 over x squared times 2x, which is just 2 over x.
Yeah. Like that. 17. And then you have to take the derivative of ln x, you put it into a second on the equation, so it's 1 times x ln e times the derivative of x dx over dx 1. And then this is 2 to another, you get 1 over x. It's the derivative is 1x ln. 1 over x and the derivative of 1 over x is just x. See, I don't know, right? That's a good question. Yeah, well, I don't know.
See, I don't even know how I started doing this.
Yeah, because it's like you're taking the natural log of x and then you just have an x. So it's
The natural log of 1 is
yes. You're welcome. My pleasure.
Bridget,
Tell me I'm
Kayla, you guys need more time on this? You need more time? No? Okay. So you guys want to look at 17?
Yes, yes.
Okay, so 17. We have y is equal to the natural log of 1 over x.
Just trying to keep it off.
So y prime would be equal to 1 over x, the ln of e times the derivative of 1 over x. Actually, the formula tells us it's 1 over u ln of a, or the base of this is log base e, times the derivative of 1 over x. So this would be equal to x. This whole thing becomes x, right? This is 1 over 1 over x is x. And the derivative of 1 over x is negative x to the negative 2 power. Right? It's easy to start off and think about this guy and know that 1 over x is the same thing as x to the negative 1. And in my mind, when I think the derivative of x to the negative 1, just the power rule, negative 1 in the front, drop it down power.
That's how we learned. We never used product rule. We just.
And then I have negative, I can add the exponents, so 1 plus negative 2 is negative 1, which simplifies to just negative 1 over x.
What happens in the book? It says that it has.
What's that?
What happens
ln of e is 1, because yeah, it's saying e raised to what power gives me this.
in the book?
Yes.
That it has to be x has to be greater than 0.
I'm sorry, I can't hear you.
In the book, it says x has to be greater than 0, which makes sense to me, but why can't it be less than 0? It just says x is greater than 0.
Oh, we're talking about this problem?
Yeah.
So for 17, it says that x must be greater than 0.
Yeah.
The reason is because you cannot have the natural log or any log of a negative value.
Okay.
Because when you raise a constant, which is going to be a positive, when you raise a positive constant to any power, any real power, it's always going to be positive. Yeah.
So if we let that without creating
Okay, so this is a good question. Let me be clear about this, guys. please make sure everyone's listening because this is regarding the points on the quiz. Grace, that's a good question. At what point, basically, you're asking at what point can we stop doing work?
Yeah,
Basically,
because, like, for me,
okay.
like, even though I know that now, I wouldn't think, oh, x can't be negative, and I wouldn't write that. I would leave that as my answer and move on. So what, like?
Yeah, I'm fine with you not. I'm not going to count off for that if you're not specifying that x must be, x must be greater than 0. I'm fine with that. But while we're on this kind of this subject about how our answers should be left for quizzes, I don't want to see this. All right, you guys can definitely go further than this because it's not going to be a choice. This can easily be simplified down much easier to this. I wasn't too focused on when we were doing those long chain rule, product rule, quotient rule, but this can easily be simplified down to this very quickly. So I would accept either this or this as a final answer for a problem like this. But it is good to know that x must, or why x must be greater than 0. Okay, so number 19. Number 19, we had y is equal to the natural log of the natural log of x. So y prime, so remember this, you have to obey chain rule, okay? So the derivative of the big picture, so the derivative of ln is just going to be 1 over whatever it is times the derivative of whatever that is. Right? Times the derivative of whatever that is, which is happens to be out of x. Okay, that's just the big picture. That's the outside, right? The derivative of ln says of whatever is 1 over u times du dx. Now u is ln of x, so 1 over ln of x times the derivative of ln of x with respect to x. And that's just the big picture. But chain rule then tells us we have to work on the inside, just like if we dealt with the trig function. Now times the derivative of the inside, the derivative of ln of x is 1 over x. So I'll do this to be clear, to show you like the two separate pieces of the chain rule. Outside, big picture, times the derivative of the guts. And then to clean this up even more, y prime would be equal to the derivative of ln of x is 1 over x. So we're going to have 1 over x. 1 over x is 1 over x squared. So x squared, I'll put it all together, ln of x. This would be your final answer now.
But that's not right. That's not the imperfect. It's 1 over x ln x. And if we just got that, that's x ln.
What I do? Let's see. 19, 1 over x ln of x. Okay, so I definitely made a mistake somewhere. The book is right. So the derivative of ln of u is just du over u. So 1 over u times the derivative of u, okay? But then times the inside of, because the chain rule, the derivative of ln of x is just 1 over x. So this is all correct. The derivative of ln of x is 1 over x. 1 over x times 1 over x is 1 over x squared.
No, because you're just multiplying ln x by x. That d over dx of the ln x is underneath that. Because you just did it. That's just you were writing it out to show us. But
Yeah.
that derivative is 1 over x. So you don't need that middle part.
Oh, I see what I did. I did like if I had sine as cosine, leave it alone. Ah, okay, thank you. So that's the mistake. Good job. So you have the derivative of this is 1 over whatever that is, but then just leave it alone, times the derivative of the inside. Yeah, so careful. This is not necessary. It's just not
Don't do
necessary.
extra work.
Don't do extra work. See? It's very easy to overthink in calculus.
Yeah, I don't know.
All right, so you can point that out.
Wait, so,
Times 1 over x, yeah?
so why do you have 1 over ln of x? Again, just say.
Yeah, so the big picture is that chain rule says, okay, the derivative of ln is 1 over whatever this is, but it shouldn't be the times the derivative of the inside.
Yeah,
That's
that's
the
the
derivative.
derivative of the inside. 1 over ln of x. It's ln of x times ln e, but you didn't write the ln e, but so the derivative of the inside of ln x right there is just x. So to take that, if you take that, this would be 1 over x times ln e, if you wrote that out. If you did it like the equation. Does that make sense?
Let's see. You definitely have the solid definitions here. So the derivative of ln of whatever, where u is a differentiable, and I know ln of x is differentiable, would be 1 over ln of x times the ln of a, which is ln of e, which is 1, times du dx.
Which is, in this case, ln of x is that the u value of ln of x.
So yeah, I
is
guess it would be fine.
Yeah.
Wow, it's an easy one to get complicated.
So, and then our question was, you can't write 1 over L.
Yeah, so that'd be it. That'd be it, yeah.
You can't write, our question was, you can't write L over 1 over ln x squared, because the natural log of x and x are two different things.
Yeah,
Right.
yeah, it's like, you can't say sine of sine is sine squared. Like, I get sine of x is not the same thing as sine of x times the sine of x.
Okay.
It's compound functions, you have to plug in one, stuff right there.
Yeah, I could see, I easily overthink that, yeah.
See, I don't think so. I got that right.
You think.
I'm gonna find weak ones with handy.
Yeah.
Okay.
It won't help in thinking. Okay.
That is that one, and that was pretty much it. Now, just be careful, you should know these for other bases too. Like, I'm just doing lots of ln's, but you should know them for other bases besides e.
Like what?
Like anything, log base 2, 3, 4, whatever.
Oh, well then it's just plug in.
Yeah, it's just plug it in the formula, yeah.
As long as it's
Just don't get too comfortable with ln and forget that the big picture is what's in brown. Are these.
Okay, so we may not just be working with natural laws, we might be working with regular laws. That makes sense.
Yeah.
So
So
if we
let's
do,
do an example off this
so
slide.
exponential and logarithmic functions, the derivatives of trig functions, and then implicit differentiation, that's what the voice is. These equations, derivatives of logarithmic and exponential functions, derivatives of trig functions, and the implicit differentiation.
Something like this, you should know that, okay, dy dx would be equal to the derivative of this. You have to plug in use the whole thing. 1 over u, so 1 over x to the 4th times the ln of whatever the base was, which was 2, times du dx, and the derivative of u is right, x would be 4x cubed. Which you could put on the top, and then it would end up being just 4 over x ln of 2. So that's an example, like, just don't get too comfortable with natural log, you just have to be basic over it.
Oh, so you have to do it on your
You want an example like this one? Or an example that deals with exponential functions?
another law. Like that one, like that.
You can do one with both.
So, let's say you have an example. You have y is equal to the log of base 5 of the anything, 5x to the 3rd power. Let's say you have something like this. Then y prime would be equal to 1 over u times the ln of whatever the base was, times du dx, which is 15x squared, which you put on top and then simplify, you know you're going to have y prime would be equal to 3 over x ln of 5, just by simplifying. Yeah, so I give you the formulas tomorrow. You just obey those formulas exactly.
That's not just a man. I'm a rebellious teenager.
That's why I had a whole list of things to because they have price loss.
Oh, great. Great. Everybody's gonna fail if I keep playing.
How you doing, Kirsten? Make sense? Yep. Okay.